So our table for tangent and cotangent, you'll notice is a little bit different than the tables we did for sine and cosine. And you'll see why once we draw the graph. So kind of weird the way I have it set up. Let's just start in the middle at 0. What is the tangent of 0? Square root of the top over square root of the bottom, so 0 over 2 would be 0. Pi over 4 is 45 degrees. Tangent of 45, radical 2 over radical 2 is 1. Pi over 2, square root of the top over square root of the bottom. Radical 4 over the square root of 0 is undefined. 3 pi over 4. It's like pi over 4, but in the second quadrant. So in the second quadrant, sine is positive, so tangent would be negative. If you think about pi, you can think about your unit circle or draw yourself a picture. Tangents y over x, 0 over -1 is 0. So my x-axis, I am going to label these pi over 4. Oh, hold on. I don't think I put enough tick marks on there. Is this the same table I have on your handout? Okay. All right, let's go ahead and we'll do the other way too. If I did negative pi over 4, that's the same as positive pi over 4, but in the fourth quadrant. In the fourth quadrant, tangent would be negative. So it would be -1. Negative pi over 2 is like pi over 2, but down here. So it's the same thing as 3 pi over 2. So -1 over 0 is undefined. -3 pi over 4 is the same as 5 pi over 4. So it's in the third quadrant. Tangent is positive. So we get 1. And negative pi, if I go that far, is the same thing as positive pi. It gives me 0. Right, so I am going to label, this is my negative pi. This would be negative pi over 2, so I'll just put tick marks for those other ones in there. Alright, so at negative pi it was 0. Negative 3 pi over 4 was 1. Negative pi over 2 is undefined. It turns out there's a vertical asymptote there. Anytime you're dividing by 0, if you remember from college algebra or pre-calc, you get a vertical asymptote. Negative pi over 4 was -1. 0, 0. Pi over 4 is +1. Pi over 2 undefined, so vertical asymptote. And 3 pi over 4 is -1. And pi is 0. When you're graphing these, we know that as you're getting closer to an asymptote, your line has to be approaching it. So it's a curve that's getting closer to these asymptotes. So it looks like this. Now actually, when I have graphed this, I've drawn more than one period of tangent. Tangent and cotangent are a little bit different than sine and cosine. You don't have to go all the way around your unit circle before they start repeating themselves. When I look at this, if I go from negative pi to positive pi, here's the up part, there's the down part, and then I'm already repeating. These graphs have a period of pi. They repeat faster. So the distance until they start repeating themselves is just pi. I graphed this from the negatives to the positives instead of going from 0 to pi over 2, just so we could get a nice section of the graph, because you notice we have asymptotes at negative pi over 2 and positive pi over 2. So So in general, when we graph tangent, we are only going to go from negative pi over 2 to positive pi over 2. And that way we can get a nice smooth curve in the middle without an asymptote chopping it up. So for their normal graph for tangent, our interval will be from negative pi over 2 to positive pi over 2. And that would give us one total cycle of our graph. Is this even or odd? Remember, even is symmetric to the y-axis. If I flip it over the y-axis, does it overlap? No. Odd is symmetric to the origin. If you flip over both, then it overlaps. So this is odd, just like sine was. So that means if you have tangent of negative x, that negative can be pulled out. Tangent of negative x is equal to negative tangent x. All right. Is that okay? Tangent and cotangent are the two that are really different than all the others. Cotangent, you'll notice this time I did go 0 to 2 pi just because I'm trying to pick a nice section of the graph. So if we go ahead and sketch this graph, so at 0, okay, cotangent is the reciprocal of tangent, so it'd be radical 4 over radical 0, so undefined. At pi over 4, radical 2 over radical 2 is 1. At pi over 2, that would be 0 over 2, which is 0. 3 pi over 4 in the second quadrant, tangent is negative, so negative 1. Pi, if you need to, think about your unit circle. Cotangent's x over y, negative 1 over 0 is undefined. 5 pi over 4 in the third quadrant, it is positive. 3 pi over 2, negative 1 over 0, or sorry, 0 over negative 1 is 0. 7 pi over 4 in the fourth quadrant, it is negative. And 2 pi, we're back to where we began. So if I plot these points, so at 0 is undefined. So we start with a vertical asymptote. At pi over 4 we get 1. Pi over 2 is 0. 3 pi over 4, negative 1. Pi is an asymptote. 5 pi over 4 is positive 1. 3 pi over 2 is 0. 7 pi over 4, negative 1. 2 pi is another asymptote. We know that as we're approaching asymptotes, we have to be getting closer to them. So these are just curves, just like tangent. And the difference was tangent was increasing and cotangent is decreasing. How many periods did I just draw here? 2. So just like tangent, the normal period is pi. If you go from 0 to 2 pi, you get 2 periods of your graph. So in general, we will typically just do an interval of 0 to pi with this one. And the reason I don't do the same period for tangent and cotangent is I want my curve to be in the middle and asymptotes to be on the ends. Is this one even or odd? If I flip it over the y-axis, we know it's just doing the same thing over here. We just have these decreasing curves. Would it overlap? No. But if I flipped over the y and the x, would it overlap? Yes. So this one is again odd. If you have a negative on your angle, that negative can get pulled out. So far, every function has been odd except for which one? Cosine. Cosine is even, but tangent, cotangent, and sine have all been odd functions. All right, so we know right now tangent is increasing, cotangent is decreasing, but otherwise they look basically the same. So what we're going to do when we graph these, we'll still do our amplitude, period, and count by, like before. The big thing to remember with these, the period is a little bit different. The normal period is pi, unlike sine and cosine, where the normal period is 2 pi. The interval can be helpful on these problems, so we were doing that kind of at the end of sine and cosine when we started having transformations. We can do it on every problem, especially with tangent when you're not starting at 0 all the time. I kind of recommend just always doing it. Then if you pick the intervals I tell you, the asymptotes have to go on both ends, and in the middle it's going to equal 0. So you can get your graph from there if you draw in your asymptotes and your 0, and then just sketch the graph from that point. So very similar process to sine and cosine, but in general those graphs look a little bit different. We're just going to practice some. So if I shoot graph tangent of 2/3 x, amplitude, just like with sine cosine, that's the number out in front. There's nothing there, so it's a 1. Period. You take your normal period divided by the coefficient of x. For tangent and cotangent, the normal period is pi divided by 2/3, and that's 3 pi over 2. So that is the first difference between sine and cosine. We're doing pi divided by instead of 2 pi. Count by, same idea, period divided by 4. And you can use your calculator on any of these that you need to, you just don't put in the pi. Interval is always helpful on these, I think, especially with tangent. Tangent and cotangent have weird intervals. We don't just go 0 to 2 pi. You can, but then you have to remember a little bit more about where the asymptotes go. So for tangent, the interval I like is from negative pi over 2 to positive pi over 2, because that way I know the asymptotes happen at the ends. And so if I were going to solve this, I would probably multiply by 3 over 2. So I get negative 3 pi over 4 less than or equal to x less than or equal to 3 pi over 4. So my first point happens negative 3 pi over 4. We need 5 total points. To get your next one, you add your count by. So if you take negative 3/4 plus 3/8, so that would be like negative 6 over 8 plus 3 over 8 is negative 3 over 8. Plus 3 over 8 is 0. Plus 3/8. Plus 3/8 is 6 pi over 8 or 3 pi over 4. And that's where we set our interval with it. amplitude is 1. Now a tangent and cotangent, that's not really a true amplitude, but I'll show you how that's helpful in just a second. Because we picked the interval we did, we know if both ends will be asymptotes. And tangent is always increasing, right? So both ends are the asymptotes. The middle is my 0. Tangent should be rising. So at negative 3 pi over 8, I will be at my negative amplitude. So I'll be at negative 1. If my amplitude were 2, I would have been at negative 2. And at positive 3 pi over 8, I'll be at positive 1. You do need to make sure you're not just drawing a line between them. It is curved and it's getting closer to your asymptotes. So it should look something like that. If you have trouble remembering if it's going up or down, always think about like 3 pi over 8. That's in the first quadrant. I know everything's positive in the first quadrant. So it has to start negative and go positive. What questions do you guys have right there? We're just going to keep practicing. If I said negative 1/2 tangent 2x, what does a negative in front do to our graph? Flip it. So amplitude, the number out in front is just 1/2. Period. Tangent and cotangent have a normal period of pi divided by the number in front of x, so pi over 2. Count by is our period divided by the 4 quadrants, so we get pi over 8. And then for tangent and cotangent, I usually always do my interval. What interval do we start with for tangent? Negative pi over 2 to positive pi over 2. An argument in the middle. So if you're trying to solve for x, you would divide by 2. So we get negative pi over 4 to positive pi over 4. So my first x-axis is going to be at negative pi over 4. If you add your count pi, we're adding pi over 8. You can think negative 1/4 plus 1/8 is negative 1/8, so negative pi over 8. Plus 1/8 is 0. Plus 1/8 is pi over 8. Plus 1/8 is pi over 4, which is where we said it should end. We picked this because then we know both ends are asymptotes. And the middle is 0. Now tangent should be increasing, but we flipped it so it will be decreasing. So at negative pi over 8, my amplitude is 1/2, so I'll be at positive 1/2. And at positive pi over 8, I'll be at negative 1/2. questions? Let's just keep trying. We'll do one more basic one here, and then we'll try some up and down and left and right. So this is cotangent. What's my amplitude? Period. Normal period for tangent and cotangent is pi divided by the number in front of x. So pi divided by 1/2 is 2 pi. Count by takes our period, divides it by 4. We get pi over 2. Interval. Okay, if I'm talking about cotangent, what interval did we set up? Look back when we said cotangent, the interval should be between 0 and pi if you want your asymptotes to be at the end. So that's not the only interval you can do. It's just a nice one. So I at 0 is less than or equal to 1/2 f, it's less than or equal to pi. And if I multiply by 2, 0 is less than x, less than 2 pi. So my amplitude is 3. 5.3. I am starting at 0. So 0 is my first point. Plus pi over 2 is pi over 2. Plus pi over 2 would be pi. Pi over 2 and 2 pi. We pick this interval so that we know both the first and the last point are an asymptote. And the middle point has to be 0. And then you just have to remember if cotangent goes up or down. But you could think like, this is kind of in essence talking about the first quadrant. We know that in the first quadrant it had to be positive. So at pi over 2 I would be at my high point, 3. 3 pi over 2 is at -3. Cotangent's decreasing. Let's sketch in my graph. It should look something like this. Sometimes people struggle to get their tangent and cotangent graphs to curve correctly. If you make your points a little bit closer together, that does help a little bit. So if your graph's turning out a little bit weird, try putting them closer together on the x-axis, and that can make it a little bit easier to draw. How are these going so far? It's just a little bit to remember. You have to know your interval and if it's increasing or decreasing. I'd like to do 2 more, and then I'll stop. So we haven't done any 2 periods. So let's do 2 periods of y equals -3 plus tangent x. What does that -3 do to our graph? My amplitude is just 1. There's no number in front. Normal period for tangent is pi. I don't have anything added or subtracted, so, or sorry, anything multiplied, so it's still pi. Count pi would be pi over 4. Interval, the interval we pick for tangent is from -pi over 2 to positive pi over 2. Again, that's not the only possible one, but that one is nice because then you get asymptotes at the ends. pi over 2 plus pi over 4 would be negative pi over 4 plus pi over 4 is 0. Pi over 4, pi over 2. I'm leaving myself a little bit of space to come in and do my second period in a minute. We know that this graph is going to go down 3. So think about how we handled that with sine and cosine. We would go to -3 and draw a dashed line. That's our center line that we're going to go above and below. Tangent has asymptotes at both ends for the starting and stopping point. And in the middle it's at 0, which in this case is going to be on this -3 line. And then does tangent increase or decrease? So my amplitude was negative, or it was 1, so here I'll be 1 below this line, and at pi over 4 I'll be 1 above. So that's my first period. Second period, we just need 4 more points. Keep adding your count by. So you're at pi over 2 plus pi over 4, be 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2. You would have another vertical asymptote at the end. And in the middle, so at pi you'd be at your 0 line. And then we're just repeating. Starts down low, goes up high. Is this going okay? Last one. So this one has a little bit of everything. What will the plus 3 do? Amplitude, the number in front is just 1. Period, I don't have anything multiplied with x, so that's just pi. Count by is just period divided by 4. Interval. Cotangent we do from 0 to pi. So if I subtract my pi over 2, it's going to take me from negative pi over 2 to positive pi over 2. negative pi over 2. If you add your count by, that's negative pi over 4. Add your count by and you get 0. If it doesn't land on 0, you don't have to put a point there. Plus pi over 4 is pi over 4. Plus pi over 4 is pi over 2. We are moving up 3, so we can go to positive 3 and draw in a dashed line for the center. And 2 is 1, so we'll just be going 1 above and below that line. So we pick this interval so that we know both ends would be asymptotes. And the middle is 0, which is on our dashed line. Cotangent. Tangent is increasing, cotangent's decreasing. So at pi over 4, I'll be 1 above this line. Sorry, negative pi over 4, I'm 1 above. At positive pi over 4, I'm 1 below. For the second period, you just add 4 more points. Keep adding your count by. Asymptotes on the ends, 0 in the middle, and the same pattern.